Hi, my name is Rob and I'm building a hypercar. And to build a hypercar we need very specialized machines. Today is the next episode in the building of our gantry mill. The mill we'll be using to build molds, plugs, everything we need to build the body of the car. And today we're doing the electronics. So the electronics or the control systems for our CNC mill has a lot of different components. Of course there's the power supplies. The 220 volt comes in, gets converted to 24 and 12 volts for the different elements, and I'll explain that in a minute. Then there's a control computer, lots of fuses, and not to forget the controllers for the stepper motors. All wired up to a front panel with all the connectors on it, where we can connect all the different external elements, like the motors. So let's take a look at those components and what we're doing here. So we start on this side. Here the power will come in, the net power will come in. There's a breaker, and then the main power adapters to go to 24 volts, which is what we need for the motors. Then there will be a distribution to a 12 volt, and that will run the computer. That computer will switch some relays for the spindle and the dust collection system, go to breakers, and then there's 6 motor controllers in the front here that will go out through the front panel and feed the different motors. So first step, I'm going to take everything out. I now know roughly where everything is going to be located. I'm going to turn the case around, drill some holes, put some feet on there, and make sure that everything is set up for us to assemble the cabinet the way we want it to. So, as with many of the parts here, this is a recycled part. It actually used to house a crypto mining system. 8 GPUs, pretty powerful system. Someone around here had a whole stack of them, so I bought a couple of the cases. They're actually pretty good cases for what we're doing today. But we'll be putting a different front on that will make it look a lot better. So that's our first holes drilled, ready for the feet to go in. Not that important, but important enough. We're setting it on the frame of the mill that you saw earlier, but I want to make sure it's a little off the ground if we put it anywhere else, because there will be screws, bolts in here to bolt down everything that's on the inside. So that's why I'm using these spacers. Makes it just a little easier to work on. So I've gone ahead and prepped the case. So I took the old front out. We're going to be replacing that with a new front. On that I've got some news here in a minute, and I mounted all of the mounting strips and cable guides. So if you come have a look in here, next thing we'll be mounting is the ground block to make sure the whole case is earthed and grounded to make this thing as safe as possible. So this is a good view why I wanted to put the legs on. You can see I've got bolts sticking out from the bottom, and this makes it easier to mount things. So now it's time to start putting components in. Obviously the mains power is the most important part, because there's a lot of cables coming from there into the system that have to be connected. I'm going to be hooking up the rest first, then connecting them to the transformers, and then putting the transformers in their place. So that's the transformer in. As you can see, it's mounted in such a way that the connectors are at the front and facing towards the case, so I can actually reach them still. And the blower, the fan, is also into the case, so there's enough circulation, so it's not going to the side of the case. The second transformer, because we need 2 of them, is going to be offset. So that means I can't reach the connectors for the first transformer anymore, but that also means it's not blocking the fan of the first transformer. So looks a little goofy, but this way I make sure that everything fits where it should be. Well, time to start putting in some components. I'll start with the first ones, and then we'll go from there. So the main components for the first axis are in now. So we have Mains coming in here, going through the breaker, going to the 24-volt power supply. That supplies power to the controller, and the computer sitting here ready to provide control signals to the controller. From the controller, the motor controller, it goes out to a plug in the front that connects up to the motor plug. So let me show you how the wiring looks. The wiring has two plugs. So there's two 6-prong plugs on the controller. 6 of those come from the controller, 2 of those come from the power supply, and 4 go to the motors. I've got one controller installed, the other one I put next to it, so you can see which one goes where. It also helps me to make sure I put the right wires in the right spot. So also to help me and make sure I do this right, because you don't want to miswire anything, I took one of the plugs that I made for the test rig, the test setup with the Arduino to have the motors run, and I know the wires are in the right spot there. So I'm using that also as a reference to make sure everything goes right. So the control wires, there's 6. 3 of those are ground, they're just looped together. And the other 3 are enable, direction, and pulse. And on every pulse, it just takes a little step, assuming the enable pin is high. I'm using 3 colors for that: light green, dark green, and orange. Same for every one of the 6 channels. On the controller board, the wires are starting from the side, step, deer, and enable. So I have to make sure on the plug, I do them in the same order. I want to use orange for step, dark green for direction, and light green for enable. So obviously I put the reference controller right here. The plug goes in this way. Let me check. Yep, the plug goes in this way, and you can see that's under enable, direction, and pulse, which is the exact opposite of what's on the board. So, and it's ground first, positive, ground, positive, ground, positive. So we'll do the light green, positive on the second slot, the dark green in the fourth slot, the orange in the first. Always important to pay attention with these. While the computer says it's a step, the controller says it's pulse, but those are the same thing. So enable and direction are called the same, but the pulse and step are called that on either side. So we go right there. So the plug goes right here. So out is more or less there. Now those signals also need a ground. I've got some nice ground wire marked. It's a DC wire, but it's yellow-green, so I figured why not use that the same. By the way, from here on out, right, there's a part here that has mains. Everything else is low voltage, 24 volts or below, so fairly safe. I'm putting 2 cables in the same hole so I can loop them through, and that's almost impossible with multi-thread wire like this. So what I'm doing is I'm putting trim sleeves on all of the wires together, so I can make them much cleaner and make the installation much safer, so there won't be any shorts in the system. So that's obviously the first one wired up. Next one is the plug that goes to the motor and has the voltage coming from the power supply, and that's the example I've got right here. It goes in like that, and on the other side we've got the motor controller that connects to that. Well, same colors to the same wire. So both examples from the test environment. So let me wire that up. On the power supply side, because it's just a screw holding it in, it's not encapsulated like with the plugs, I like to put the sleeves on just to make sure that it stays nice and tight. So, ready to go. So that's the basic wiring installed, but there's something extra we want to do. This would work, but in order to check that everything is running the way I want it to, I've added volt and amperage meters to every one of the motors. They won't be perfect, they won't be very precise, but they'll be enough for me to see if I'm drawing too much power or if there's anything else that is a little fishy. So I'm adding a voltage meter, so let me wire that in. I'm taking the power wires back off, and to the positive side I'm adding the feed wires for the voltage meter, and the ground side I'm actually combining two wires together. So what we're doing here is we're actually putting the amperage meter in between the wires for the ground. So the red goes to the load. So that's that side, and the black is connected to the black on that side. Let's solder those. Well, that's the first plug fully connected with the voltage control and the amperage meter on there, and of course the front faceplate connector. So that goes in there like that. On the front connector, we still need to do the sensor, right? That needs to go back to the computer, as well as the emergency stop. So we'll do that next. So obviously, the plugs for the motor are going to be mounted in the front panel, mounted nicely, and so are the voltage meters. So let me plug one in so we can at least have a start. So I'm not pushing it in all the way now. I've also got mounts for this to mount it solidly. For now, this is fine for what we're trying to do. Let me hook up a mains wire to the power supply, and then we'll at least test if this works or if we're going to let the magic smoke out. Well, this is a quick wire job, not entirely up to code, but don't tell anyone, I won't. So let's try if it works. Well, there we go. 24 volts, and it says it's using 0.02 amps. I'm guessing that's the power that the meter uses. That's fine. Now if we attach the motor, we can actually monitor how much power that motor uses and if the power supply is up for the task. So the front panel has the 6 motor controllers and a 7 plug, the same plug but wired differently, obviously, and that, for example, connects the emergency stop. Well, because we're going for the normally closed setup with the emergency stop, with the plugs, if they get unplugged, also triggering that same loop has to go on the emergency stop button. So let's wire in the bases for that, and then we'll at least have the first controller wired in completely. So I've already wired in the emergency stop button to the plug from the outside. This is one that's chassis mounted, and if I put that on, I can see it is the first 2, or depending on what side you look on, the last 2 connectors. So we'll be looping the emergency stop through that. To wire the emergency stop, I'm going to use a bright red wire. So it will be a bright red wire throughout the environment that is the emergency stop. Just to make sure, we'll check which wire it goes in. So let's do that first. So here we can see that the 4 control wires left to right. So the 2 on the right should be the emergency stop switch. So let's go back and make sure we connect it to the right one. So the loop starts where the emergency button is. Doesn't really matter where it starts, right? It's just a loop. So as long as it's connected all the way through, we're fine. And then from here, it goes to the emergency stop switch, which is one of those connectors right there. Don't know exactly which one, but for now we'll keep the wire a little longer so we know it's long enough, and we'll connect it when we get to that part. So off camera I completed a lot of the wiring, just you know, it's same, so repeat over and over again. When we left you, I had one of the motor controllers in. Well, now all 6 are in. The first 3 are mostly wired, a couple of things left to do. The other 3 are just stubs are in. The other part that's been wired in completely is the whole safety stop system. So it's wired from the emergency switch, also one on the case. Turn it on or turn it off, take the key out, and the machine will just not operate. Looping to all of the motor controllers, all of the plugs that I showed you earlier. And then there's a switch on the case that will switch off the whole system as soon as you take the case open. Next step is to put the front panel on and make that all work. But for that, we need the front panel. So let's go pick that up at our sponsor, Snylab. So here we are at Snylab. Let's see what parts they have for us. Well, very happy with the part. Let's see what it looks like when we install it. Let's put it together. Let's put all the different parts on. Let's first reveal what it looks like, because I think it's kind of pretty. So, bright blue, that will definitely show. So, let's start putting some parts on and make this complete. So I've assembled the main elements of the front control panel, so let's start installing that. So it's turned around from the last time we showed you this, but mains power comes in from here. It's got a breaker on there, the switch, 2 power supplies for 24 volts that feed the 6 controllers for the 6 stepper motors. There is the main computer right here, a 12-volt transformer to feed the main computer and the cooling fan, and then 2 relays that the computer can control to switch on 2 outlets for the spindle and the dust separator. Obviously, most of the wiring is here. It's from the computer to the controllers. Each of the controllers has 12 connectors. 6 of those are for signal from the computer, and the other 6 are the output to the motor and the main power from the power supplies on the left, the 24 volt going out to the motors. And then we're measuring all of that, both the voltage and the amperage of each of the controllers. And why am I measuring all of the amperage per channel? Also, I can see how much power each of the motors actually pulls. Fairly clean wiring. Is it professional grade? No, not even close, but I'm very happy with it. The other thing that's in here that's interesting to notice is there's a couple of wires that we're not using. There's a key switch on the front panel, so it can turn on and off, and you can take the key out. That is on the loop for the emergency stop. That goes through every switch and also to the case switch. So right now, even if everything else would be hooked up, the system wouldn't work because the emergency stop is on because the top of the case is off. Same as if the keys are out or if any of the motors get unplugged, the thing will just stop. So this is what it looks like when you turn it on. If you ever do something like this, be very careful. You can see the top is not on. There's mains power, open wire, well, relatively open wires in here, but let's see what happens when you turn it on. You can hear that, but the cooling fan starts going. All of the controllers come on, and I think you can see all of the gauges come on with the voltages and the amperages. This is also the problem with these very cheap Chinese voltage and amp meters. They're not all quite the same. They're close, but not perfect. But for what we're doing here, plenty good enough. So now that the controller is running, the next step is configuring the software. So that should work right here, right now. So let's give it a go. The controls are here, Fluid CNC, by the way, Fluid NC. I'm also planning to add a game controller, so I've got a remote dongle that I can use to make the gantry move and to make positioning easier, but that's something for a future project. So that's all for the electronics for the gantry mill. It's all installed, it's all hooked up. All the different motors for the 4 axes are hooked up. I'll be dialing in the software a little bit, and then next video we'll be showing you how the CNC Gantry Mill works. So look forward to seeing you then. And don't forget to subscribe, comment, like, and of course tell your friends about us.